In this video, I will go over the homework that follows the lecture 8.3, integration by parts. And as always, I hope you watched the lecture because I will be referring to some of the material from the lecture, assuming that you have familiarized yourself with it. So let's go ahead and get started with homework. And the first problem is right in front of us. We need to find the integral of 6x squared e to the power 4x dx. And this is going to be one of the patterns that you should be able to recognize. So we set it up for the integration by parts. U is going to be 6x squared and dv is e to the 4x dx, and du is 12x dx, and v is 1/4 e to the 4x. It's a simple integration by, well, not by, but with substitution. And the result of this integration by parts is 6/4 x squared e to the 4x minus integral of v du, so it's going to be 1/4 e to the 4x times 12x dx. And here you can see we can simplify it a little bit, so we have the following. And I'm going to rearrange the integrand so we can see the pattern. The pattern suggests another integration by parts. So my u is x, my du is dx, my dv is e to the 4x dx, so that my v is 1/4 e to the 4x again. And now it's important for you to remember that the integration by parts only addresses this integral, right? So everything else remains intact. So let me make some space for this to write out this result, and we write out uv minus integral v du, and we're at the finish line. So we have 3/2 x squared e to the 4x. Now we're going to distribute the 3, so we have 3/4 x e to the 4x, plus we're going to distribute 3, but we have 1/4. And now here, instead of writing integral of e to the 4x dx, I'm actually going to just find that antiderivative. So it's 1/4 e to the 4x plus c. And frequently we have a lot that we can factor out. So let's just take out e to the 4x, and we have 3/2 x squared minus 3/4 x plus 3 over 16 plus c. Looks like we could have also take out the 3 without too much effort. But I mean, since we're doing this, let's just take out 16 in the denominator. So that will leave us with 8x squared, 4x, and 1 over here. So that's the final answer. So we have 3/16 e to the power 4x times, we have polynomial 8x squared minus 4x plus 1 plus c. Alright, let's take a look at another problem. Problem number 2, we have an integral of ln x squared divided by 5x to the power 5 dx. Again, this is one of the patterns that you will learn to recognize. We're going to choose u to be ln of x to the power 2, so that du is 2 ln x times the derivative of ln x, which is 1 over x dx, and the dv is 1/5 x to the power negative 5 dx, meaning that v is going to be we're gonna have x to the negative 6, so it's gonna be negative 1 over 30 x to the negative we're actually adding 1, right? So it's going to be x to the negative 4, which is this, divided by negative 4, which is where the negative 1 over 20 will come from. And that's my setup. Now let's plug everything in. So we have negative ln of x squared over 20x to the 4, that's my uv, minus v du. So, but I have that extra minus there, so it's going to be plus integral. And you can see like 2 over 20 will give you 1/10. And we have integral of ln x in the numerator, but in the denominator we're going to have x to the power 5. And again, it's the same pattern which calls for the same integration by parts. So u is ln x, du is 1 over x dx, dv is x to the negative 5 dx. So v is going to be negative 4x to the power 4. And plugging everything in. So again, remember that integration by parts only applies to this. So this remains intact. It's not part of integration by parts. And now we write the integration by parts inside of this parenthesis. So we have uv, so ln of x over 4x to the 4, minus v du, so it becomes plus 1/4 integral of 1 over x to the power 5 dx. There's no benefit in writing it as x to the power 5 in the denominator. I'm just going to write it as x to the power negative 5, as I've been writing it this whole time. So the final answer is negative ln of x squared over 20x to the 4 minus, I'm distributing now the 1/10, so we have minus ln of x over 40x to the 4, and here we have plus 1 over 40, and x to the negative 5, it's 1 over negative 4x to the power 4 plus c. So we can take out a lot here. Essentially want to we can take out the negative negative 1 over 160 x to the power 4. So what's left here is 8 ln x squared plus 4 ln x plus 1. So hopefully, not hopefully, but this is the right answer. That's the confidence we want to have. but hopefully we didn't make any typos. So we have here 8 ln of x squared plus 4 ln of x plus 1, and in the denominator we have 160x to the power 4, and we have plus c at the end. And we nailed it. Let's do another problem. We have integral of 7x squared sine 2x, and we're going to recognize the pattern and do integration by parts. So my u is 7x squared, my du is 14x dx, so my dv is sine of 2x dx, so that my v is actually negative 1/2 cosine of 2x. That's from here to here we go by integration via linear substitution, t equals 2x. So now plugging in the results, we have uv negative 7/2 x squared cosine of 2x minus, but we have the minus there, so it's going to be a plus, the integral of 14x times 1/2 cosine 2x dx. And we can do like some basic maintenance here and take that 14 over 2, which is 7, outside of this integral. And as soon as you do that, what do we recognize here? We recognize an opportunity to do integration by parts again. So u is equal to x, du is equal to dx, dv is equal to cosine of 2x dx, so that v is equal to 1/2 sine of 2x. And now the most important step here is not to lose track of your own work. So the integration by parts, the result of it will be written inside of the parentheses here. So we have uv minus integral of 1/2 sine of 2x dx. So the final answer is distributing everything, so 7/2 x sine of 2x. And now I'm going to distribute 7 over to this integral, take out 1/2, so we have negative 7/2. But the integral of sine of 2x is going to be negative 1/2 cosine of 2x and plus c. So this is the final answer. So let's type it up. Negative 7 over 2 x squared cosine of 2x plus 7 over 2 x sine of 2x plus 7 over 4 cosine of 2x plus c. Let's do another problem. similar to the previous one. So we have integral of 9x squared sine 4x dx. We recognize the pattern, so we set up integration by parts. U is equal to 9x squared, du is equal to 18x dx, dv is equal to sine 4x dx, so that v is equal to negative 1/4 cosine of 4x. I have an integral. Sorry, too fast. We have uv, so negative 9/4 x squared cosine of 4x minus, but combined with that minus it will be plus, v du, so we can take out 18/4, and we have integral of v du, so we have x cosine of 4x dx. And again, it's the same pattern, so we recognize it. We set u to be x, so that du is dx, and then dv is cosine of 4x dx, so that v is equal to 1/4 sine of 4x. Continuing this solution, we have negative 9/4 x squared cosine 4x plus, we have 18/4, which is 9/2. And here I'm going to write the result of the second integration by parts. So it's uv minus integral of v du and we now are at the finish line. So we have negative 9/4 x squared cosine 4x plus 9/8 x sine of 4x minus, and now here we're distributing 9/2 over here, and at the same time we integrating this, so 1/4 comes out, so we have 9/8 times another 1/4, so it's 9/32 times negative cosine, so this becomes positive, of 4x plus c. That's the final answer. So let's type this up. I have negative 9/4 x squared cosine of 4x plus 9/8x sine of 4x plus 9/32 cosine of 4x plus c. And we did great work over here. And we are done. So if you need any help with applying integration by parts twice, please let me know.